Okay, what is the sum of each distinct prime factor of 9,999? So there are a few ways to think about this. One way to think about this would be to divide it by 9 and then to divide it by whatever else we could find. Another way to think about this, incidentally, this number is 10,000 minus 1. Because it's 10,000 minus 1, or 100 squared minus 1, means that we can factor this according to the difference of two square pattern. And so this would be factored into 100 minus 1 times 100 plus 1. And of course that would be 99 times 101. Now 99, of course, we can factor that into 9 times 11, or 3 times 3 times 11. And 101, let's think about this. 101 is obviously not divisible by 2 or 5. It's not divisible by 3 because the sum of its digits is not 3. If we think about trying to divide it by 7, we know that 7 goes into 91, 7 goes into 98, and 105. So 101 is not a multiple of 7. Because it is not divisible by any prime number less than 10, that means that it must be a prime number. And in fact, 101 is a prime number. And so the distinct prime factors are 3, 11, and 101. Those are the three distinct prime factors of this number. When we add these up, we get 115, which is the sum of the distinct prime factors of this number.
Okay, let's begin with the first equation we're given. From here, if we divide both sides by 4, we get a equals 9/4 times b. Since a and b are both positive, we know that a must be larger than b. So I'll add this here. Now let's look at the third piece of information. If we divide both sides of this equation by 5, we see that it must be the case that c is larger than a. So we'll add this to our inequality we have at the top. Finally, we'll examine the second equation. If we divide both sides here by 17, we get c equals 11/17 times d, which means d must be larger than c. So we'll add this to our top inequality. So now we see that b is our smallest number and d is our largest number. Keep in mind that we need to arrange these numbers from greatest to least, so our answer must be c. Okay, let's begin with the first equation we're given. From here, if we divide both sides by 4, we get a equals 9/4 times b. Since a and b are both positive, we know that a must be larger than b. So I'll add this here. Now let's look at the third piece of information. If we divide both sides of this equation by 5, we see that it must be the case that c is larger than a. So we'll add this to our inequality we have at the top. Finally, we'll examine the second equation. If we divide both sides here by 17, we get c equals 11/17 times d, which means d must be larger than c. So we'll add this to our top inequality. So now we see that b is our smallest number and d is our largest number. Keep in mind that we need to arrange these numbers from greatest to least, so our answer must be c. Let's begin by solving each of our equations for x and for y. We'll begin with this equation. If the absolute value of x plus 5 equals 3, then we know that either x plus 5 equals 3 or x plus 5 equals -3. When we solve these two equations for x, we get two possible values. Now let's solve our second equation. We'll begin here by multiplying both sides by 3. And now, if the absolute value of 2y minus 1 equals 15, then either 2y minus 1 equals 15 or 2y minus 1 equals -15. When we solve these two equations for y, we get two possible values. Now let's check our answer choices. We'll begin with A. Can we find a value for x and a value for y such that the absolute value of x plus y equals 0? The answer here is yes. When x equals -8 and y equals 8, then the absolute value of x plus y does equal 0. Similarly, we can find values for x and y such that the absolute value of x plus y equals 6. And we can do this also for answer choices D and E. So since we cannot eliminate answer choice C, this must be our answer. Okay, let's rewrite our equation over here. Now the big step to solving this question is to recognize that we can factor out of the left-hand side an 8 to the power of n. When we do this, we get inside the brackets 8 to the power of 1 plus 1. We can now evaluate the portion inside the brackets to be 9. And now we can divide both sides of this equation by 9. At this point, it's going to be useful to rewrite both sides of our equation using the same base. So we'll take our 8, for example, and rewrite it as 2 to the power of 3. And we'll rewrite our 4 as 2 to the power of 2. We can now simplify the left-hand side to be 2 to the power of 3n. And now we have an equation where both sides are using the same base. We can now conclude that our exponents must be equal. Finally, we'll divide both sides of this equation by 3 to get n equals 2/3, so our answer is D. Okay, let's move our inequality over here. And our first step should be to divide both sides of the inequality by 6 to get the following. At this point, we should recognize that if the absolute value of this expression is greater than 2, we can conclude that this expression is either greater than 2 or the expression is less than -2. We now have two different inequalities we can solve for k. Let's begin with this one. First, we'll subtract 4 from both sides. And now, to isolate k, we will multiply both sides by -3. When we do this on the left-hand side, we get k, and on the right-hand side, we get 6. Now, since we're multiplying both sides of an inequality by a negative value, we must reverse the direction of the inequality. Okay, now let's solve this inequality for k as well. First, we'll subtract 4 from both sides, and now we'll multiply both sides by -3 to get the following. We now have two different inequalities involving k. This one tells us that k is less than 6. This means that k can have any of the following values. Next, we're told that k is greater than 18, which means k could have this value. And we have now identified all possible values of k.
If p and q are the solutions to this equation, x squared plus 13x minus 48, then what is the value of p minus q squared? Well, that equation is a quadratic. And of course, the way we solve a quadratic is to put everything on one side equal to 0. So I'm going to subtract 48 from both sides. I'm going to get x squared plus 13x minus 48 equals 0. So we need a number we need two numbers, one positive, one negative. Their absolute values should be relatively far apart. So they have a product of 48, and the difference between the absolute values is 13. And it turns out that 3 and 16 fit the bill. 3 and 16 are 13 units apart, and they have a product of 48. And so we're going to make the bigger one positive, x plus 16, x minus 3. That is the factored version of this. And this produces roots of x equals -16 and x equals positive 3. Oops, positive 3. We don't know which one of these is p and which one of these is q. And so it might be that we're going to get p minus q. It could be -16 minus 3, which is -19, or it could be 3 minus -16, or 3 plus 16, which is positive 19. So we don't know the value of p minus q. It could be -19 or positive 19, but it doesn't actually matter because we're squaring it. And when we square, everything is positive. So 19 squared, as it turns out, is 361. And 361 is the answer. So very interesting. We have 3x is less than 2y is less than 0. So 3x is a negative number, 2y is a negative number, 3x is a negative number with a bigger absolute value. And so here we have, so this is the bigger one and this is the smaller one. So this is negative small and negative big. Well, the first one, we have negative small, and then minus the negative big is the same as positive big. So that would be positive. So that would be greater than 0. So 0 is not the greatest. This one would be negative big plus positive small. That would be negative. So that's not going to work. This would be negative big. This would be the same thing. So this would be positive. In fact, this equals, this just reverses the order of subtraction. This equals 3x. So C and A are equal. But notice what D does. D takes their sum, so their sum is going to be really negative, but then makes that negative. And so what we get here essentially is the absolute value of 3x plus the absolute value of 2y. And so we get both of their positive, we get the big number, the positive big number, plus the positive small number, all added together. And that's going to be much bigger than any difference between them. And so D is definitely the largest of all of these.